So chapter 5 is going to be split up a little bit differently. Probably going to have some uploadable assignments where you do it and you just like scan it and send it to me. So it's not going to really be broke down into units like it has been in the past. I'm just going to talk about concepts. So really what chapter 5 is about solving systems of equations. Okay, so here's an example of a system of equations. We have two equations that are linked together where the x and y in one equation is the same x and y in the other equation. And so whatever value of x and y that satisfy this guy up here has to also be the exact same x and y to satisfy this down here. Okay, so this little squiggly bracket over here shows that they're linked together. They're a system. Okay? Now, there's several different ways of solving this. I'm going to go over a couple different ways. The important thing to remember is you need as many equations as you have variables. So this one has two equations, two variables, so we can solve it. Because if you only have one equation and two variables, you can't solve for both of those variables. So you have to have another equation to compare it to. So you can see right here, we can actually do this one in our head. What two numbers add up to 5, and then if you subtract them, you get 1. You get 3 plus 2 equals 5, and 3 minus 2 equals 1. So that's x equal to 3, y equal to 1. Well, it's not always going to be that easy. We're going to have to do different ways. So the first way we're going to talk about is called substitution. Substitution says if x and y are the same in both equations, then it's going to be the same in the other one. So we can substitute in for that variable if we can solve for a variable. For instance, on this first equation, you can see that I can easily solve for y by subtracting 3x from both sides. So that gives me y equals 13 minus 3x. Okay, so if y equals that, then y has to equal that in the other equation as well. So I can substitute that guy in, and we have now got it down to one equation. So then we get 2x minus 65 plus 15x equals negative 14. That's going to be 17x minus 65 equals negative 14, which is 17x equals 51, and then divided by 17x equals 3. Okay, now we're not done because we've got to solve for y. We can take our x and run back up here and plug it in for the x up here to go ahead and solve for y. So y equals 13 minus 3 times 3. That's 13 minus 9, or y is equal to 4. So there is our solution. X equal to 3, y equal to 4. That's how we solve our system. Let's do another example similar to that. No, let's go on to something else. I'm going to show you another way first, and we'll talk about which way is better. The next way is called elimination. Okay, so elimination says if these equations, if we know that x and y, these equations are the same, we can add them together, and the resulting equation is going to be the same x and y as well. So here, if we add these two guys together, you see that these two variables eliminate from each other. And gives us 2y equals 8 and y equals 4. Then we can take that and plug it into either equation to find x. So 2x minus 3 times 4 equals negative 16. That's going to be 2x minus 12 equals negative 16. Add 12 to both sides. 2x equals negative 4, and x equals negative 2. There's our solution. Okay, that's elimination. Elimination is a little bit easier way of doing it. Well, that way, the one I just showed you, you see that the -2 and the 2 matched up. What if that wasn't the case? What if we had something like this? 3x plus 5y equals -7, and we have 6x minus 2y equals 10. Well, here we don't have those variables that matched up. But these two, I can multiply one of them, and if I multiply everything in the equation by the same number, it's still the same equation. So when I do that, I get -6x minus 10y equals 14. Then you see that I have my x's match up as opposites, so that when I add them, I get -12y equals 24. Then divide both sides by 12, y equals -2. Substitute it into one of the equations. 3x plus 5 times -2 equals -7. That's going to be 3x minus 10 equals -7. Add 10 to both sides. 3x equals 3. X equals 1. There's our new solution. Okay? And now, that one I had to multiply just one equation. I could have to multiply both equations. Here's another example using elimination. 3x minus 4y equals 1. And 2x plus 3y equals 12. Okay, so I can look at these guys and see they're not going to match up. Okay, and I can't just multiply one of them. So what I'm going to do now is I'm going to multiply this guy by 2 and this guy by -3. And that is going to make them guys match up. So it's going to be 6x minus 8y equals 2. -6x minus 9y equals -36. And when we add those together, we have -17y equals -34. Divide both sides by -17, we get y equals 2. Substitute that into one of the equations. We'll go with the top one. That's going to be 3x minus 8 equals 1. Add 8 to both sides. 3x equals 9. X equals 3. There is our solution. Okay, let's talk about a special case. A couple of different special cases. Because we are talking about multiple things going on, there is possibilities for having no solutions. So let's look at the different possibilities we can have. Here's the first possibility. Again, I need to multiply by 2 here, make those guys match up. I get 6x minus 4y equals 8. On the bottom, it stays the same. And look what happens. When I add them together, everything on the left goes away, and this gives me 15. Now, does 0 equal 15? No. If we have a not true statement, that means that these equations don't balance out. So all we say with this is that they are inconsistent. And what they actually are, because these are linear lines, they're actually parallel lines. So they never cross, so there's no solution. We'll call this an inconsistent system. Our other way is we have 8x minus 2y equals -4 and -4x plus y equals 2. Multiply everything on downstairs by 2. Gives me 8x minus 2y equals -4 and -8x plus 2y equals 4. Everything goes away on both sides. That actually is that they're the same line. So we call this a dependent system. And there is infinitely many solutions. Because they're the same line. Anything you put in is going to be the exact same in the other one. Okay? So that's all for 2x2 systems.